Good morning to one and all. In this short video, let us discuss on the Bernoulli's principle and its applications. That is the case study of Bernoulli's principle, where it can be used and how it can be used. So, the Bernoulli's principle is based on three things. One is a theory and application and conclusion. So, yeah, when we speak about the theory of Bernoulli's principle, we have seen the Bernoulli's equation in our unit 2, so which has pressure head, velocity head, and a datum head. So these three plays a vital role in all the places where hydraulic fluids are applied. So this is the introduction of Bernoulli's principle, which is found by Daniel Bernoulli in his book Hydrodynamica in 1738 itself. So Bernoulli's principle states that the total mechanical energy of the moving fluid, comprising the gravitational potential energy of elevation, the energy associated with the fluid pressure, and the kinetic energy of the fluid motion, remains constant. So what it means is, we have seen in the Bernoulli's derivation that the pressure head plus velocity head plus datum head is always a constant. The assumptions itself shows that all these three, summation of all these three is a constant. So this is another thing which represents the pipe, which shows the Bernoulli's equation, which we have written in the form of pressure head, velocity head, and datum head. So the base is called as the datum, and this is the inlet size of the pipe, and this is the outlet size of the pipe. So like this, we can have many applications such as a venturi meter, orifice meter, friction in pipes, and so on. So the Bernoulli's equation formula is a relation between pressure, kinetic energy, and gravitational potential energy of a fluid in a container. This is the equation which shows the Bernoulli's principle. So P1 plus half rho V1 square plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. So wherein the previous diagram we have seen cross section 1 and cross section 2. So where P is the pressure, rho is density, V is mean velocity, and height, H is the elevation head from the ground. That is the elevation head of the center of the cross section with respect to the datum. So these are all the next slide. The upcoming slides shows the various applications of Bernoulli's principle. So this is the application in lift. There is aerospace applications wherein the fast air moving over the wing has a lower pressure, and the slower air moving under the wing will have a higher pressure. So this is the direction of the flight, and here the Bernoulli's principle is in use. And the next thing is here the airfoil, how it works, it's shown here, and this is the lift principle we have shown in the diagram. So the next one is the spoilers, that is spoiler provides a better stability and avoids lift. And the other one is the carburetor application, which we can see in the engines. So here also the Bernoulli's principle is used. And the next principle is atomizer and ping pong ball. So these two are also another examples of Bernoulli's principle. And the other some few examples or applications of Bernoulli's principle, like a tennis ball, baseball, and mountains. So wherein the low pressure region and high pressure region comes into picture, and the potential energy, pressure energy, and kinetic energy all are included in this. So this is what about Bernoulli's principle. And when we see that all the fluid applications where the hydraulic fluids are used, the Bernoulli's principle can be applied, wherein the datum head is existing. So datum head in the sense, when we speak about a reservoir or a tank where the water is stored in our domestic purpose. So the water flows from a certain height. So there the datum is fixed. So it will flow from one height, and it is collected in the other region, and the flow of fluid and the discharge of fluid from one end to another end, there also we are following the Bernoulli's principle. So the continuity equation, Q equal to A into V, that is discharge is equal to area into velocity, area of the pipe into velocity of the fluid flowing inside the pipe. So the continuity equation is also another underlying important factor when Bernoulli's principles are considered. So in the next video, let us discuss on the continuity equation and the link between the continuity equation and Bernoulli's principle. Thank you.